ke molebeledi wa Bathabane. I'm presenting this title on behalf of two colleagues, Dr. Mafonko, who is the PVO Northwest based in Maung, and Dr. Mboy Ramukwena, who is the PVO in Okavango. Basically why we teamed out, because this is basically a field-based data, what we have seen, what we have been told, and what we have done. I think that's exactly the nature of this presentation. Not to judge, but to present our experiences objectively for you to assess, help, and evaluate. Basically, the outline. There's someone is. Can you get rid of that? Yeah, I mean the outline. I'll just go into the background, the tick abundance, as in terms of infection intensity in cattle. What we figured out as the ticks we have seen and the associated challenges, and then we go into the control and the challenges and what we think is the way forward going forward. Now, a little bit of background. As you know, Ngamiland has got about 6 subzones. Currently now, because of the upgrading of the Okavango sub-district to a full district, we have got about 4 of those now in the Okavango, being zone A, B, and part of C and F. And we have got about 4 also, which is in Northwest. As far as the boundaries are concerned, it's an imaginary line somewhere depending on who wants to assess it or not. And you know, the current numbers in Ngamiland in terms of cattle, goats, and sheep and pigs as evaluated during routine vaccinations, these could not be exact because they are not really censuses as shown there, and this is based on the 2023 vaccination figures, of course unpublished, so you can add plus or minus depending on what we know is our return rates for vaccinations. Now, you know, in Ngamiland, particularly along the lower Okavango Delta, which are the mouth of the tributaries of the Delta, you are looking at probably about 100 livestock units per square kilometer. That's quite intense. And that's not really the average across the whole district, because Ngamiland is vast with some areas which have got Womokhau and farmers try by all means to avoid those. Fences, of course, you know, 1,579 kilometers. That's from here to Kasani and back up to somewhere, maybe as far as Mahalape. But you remember, you can double this because a lot of those are double fences. This is just basically a length. But if you look at the actual fence infrastructure itself, it's probably almost 3,000, nearly a quarter to the UK from Botswana, which is 10,000. They've got about 31 extension areas between Ngamiland and Okavango, 14 in the Northwest and 17 in the Okavango. And out of those in Okavango, 7 are only manned. And here we are talking about permanent employed Bakenti. It could be more based on the temporary Bakenti which are employed on 6 months basis, but you really can't plan on temporary things, can you? You can't. So the PVO is planning on the 7th one, which he can. But remember, that's across the whole district. So some of those also have to do administrative work, so they're not really at the extension level. And in Maung, we've got only 6 permanent Bakenti, the whole district, out of the 14 extension areas. And they are serviced by 2 veterinarians based in Maung and 1 based in the Okavango. And the one in Okavango is also the acting DEC. Mr. Muladi Kuduman, can you lower your icon there? You are online, so you can't do much. Okay, now, what is the story with the tick abundance? You know, the studies which have been done in Botswana were done back in the 1980s. So that's the current data we have. So as far as investigation of ticks, this is one of the few studies we have done in 2021. So you can look at the difference between the 1980s by a German NGO and what we done. So what we did there, recently we did a two-stage quota sampling design. It is an abattoir-based study where we're looking at to predict basically tick abundance, which is intensity of infestation on cattle. The aim was to predict this within 10 percentage points of the true proportion with 95% confidence. Basically, we went to the abattoir, and as animals come in, we're lifting the tail and counting just at the ano vulva region. You know, we know ticks have a preferential site, but you couldn't actually start going underneath the animals in a large, and with the abattoir manager wanting to slaughter and make business. So this was the easier part. And we did that over the whole seasons, so over a year. And normally in our terrain, this winter, summer, autumn thing don't really work. So we have got a way of research-based seasons where we say cold, dry, which looks at those months, late, hot, dry, and wet, and early dry. They are really relevant for kind of those studies. So what did we find out? Obviously, we find increased infestation just by being female. So female cows carry more ticks than male cows, and that is a physiological thing based on the hormone, particularly when they are calving and stuff like that. And we also find there's a decrease in tick infestation with good body condition score. So basically, animals in good body condition score carry less tick. That's to do with the immunity to fight the ticks and all those. So what it means is during the drought season, you also see more ticks on animals. And as you move from the cold to the wet seasons, obviously the tick intensity increases in animals. These are critical parameters, particularly when you want to devise a targeted control strategy. And we also, this is now to do with Ngamiland, because Ngamiland is a peculiar area. You get the rainy season, but then during the dry season, you get floods coming in. It presents a particular ecosystem, unique ecosystem for ticks in Botswana. So you also find that there is a clustering of ticks during the late hot season. That is your September, October, November. Ticks are no longer uniformly distributed across the district, but they are now clustered. And that clustering, we realize it gives you a high tick count on crashes located along the seasonal floodplains. So for whatever reasons, the late hot season comes, ticks seems to gather along the tributaries, the seasonal floodplains. And now you get low tick counts on those located on the dry grasslands. So if you are up in the sand veils, you don't really get ticks. You get few ticks, but as it comes to the tributaries, more ticks congregate there. And we're thinking, is this perchance finding? So we did a Moran's eye test, and we realized this is highly significant. It's not a random thing. It's something is beyond a chance. We did also a hot spots analysis along the tributaries, and you can see the red spots all falls along the tributaries. Along the Tamalakani, you go down to Buteti, and as you go down on the sand velds, few ticks. So we are confident, scientifically proven, that tick clustering during the late dry season occurs along the floodplains. Conclusion, from that studies we have figured out cattle tick abundance is fluid largely by season of the year in Ngamiland. And the micro conditions brought about by the seasonal flooding of the delta have a decided effects on the distribution during the driest of the season. And I want you to have that in the back of your mind as we go look at the distribution of dermatophilosis and the actual drivers for that. in terms of these floodplains. Okay, so tick-associated challenges, there are many, which we have figured out in Ngamiland. I think there's the last one, yeah? So hot water, we've diagnosed that laboratorily in Shorobe in 2023. Besnoitis, which is sort of the elephant disease, we've figured out in Sihitwa areas and Komana. Sweating sickness is all over the district. Anaplasmosis, we diagnosed that in Karing 2011. Rickettsiosis, we don't know whether it exists. Of course, if you don't look for it, you won't find it. East Coast fever, we know areas like Kasani, down in Nata last year because of the buffalo incursions. Why wouldn't it be in Ngamiland? Again, if you don't look for it, you won't find it. Babesiosis, the bovine version so far, we have never had a diagnosis of that in Ngamiland. Whether it exists or not is out there as a question mark. Now, we'll focus largely on dermatophilosis as our case study for this presentation. Really, the first detected cases in Northwest District were in 2015. That is Gumare, Nukaning, and Tubu. And if you actually look at those extension areas vis-a-vis the delta, you see they fall within the delta tributaries. It was reported in the Eastern Panhandle, Beta and Eretsa in 3 years later in 2018, affecting the 3 crashes we've mentioned there. But later on, it has gone on through the whole of the Panhandle. So basically, when you talk of Sinkobo these days, you're talking the whole of Ngamiland. So November 2023, the first cases of heavy tick infestation came down back to Shorobe. So you can see the Panhandle, you go on Tubi, you come on Shorobe, all along the peripheries of the delta. That's where you've got this problem. Nothing on the Karing area, nothing on the Heinaveld. So you go to the farmers, there's the problem. Where does it come from? The farmers will tell you, elephants brought it. They brought the bond tick and the Sinkobo disease. That's the belief of the farmers. Yeah. Scientists will tell you the tick, because of our poverty alleviation procedures, Minister, we buy all these animals, be cattle, be small stock, and you supply farmers. But there isn't also a biosecurity measure to say to move these ticks from one area to another one. These are the things you do in terms of ticks. If you are happy there's no FMD, we are happy to load them. So we could also be bringing things. But because these animals are given to farmers, farmers don't like pointing problems to their own stock. You know, the problem has to come somewhere. So they always point to the elephants. What has been the impact? 2015 to 2019, that short period. In Gumare and Nukanen, the Maung office went in to ask farmers to say, what have you lost? And this is the figures farmers gave. 16,000 almost cattle, 18,000 goats, almost 2,000 horses, 1,300 and something donkeys, and 559 sheep. This is what the farmer says they've lost. Then we tried to verify those during the treatment and dipping exercise. I was still with DVS by then. But there were kind of different issues. The way it was not only us as DVS finding the figures. Politicians were up in arms. Farmers are losing animals. And you should remember also, we had voted in 2040. So 2015 to 2019 was, 2019 was the election year. So the way this information was discussed with the farmers and asked to do by those on the grounds during the campaign, it was more like a canvassing kind of a thing. So we also felt the farmers gave this statistics with the hope that there will be compensation from government. If people are promising, why not extend your arms longer? Yeah, that's the kind of things we're thinking about. Also, we figured out that whole year of 2019 it was really a drought year. But then, in every situation now, there are predisposing factors and actually the killer. So which was what? Was Sinkobo the predisposing to animals dying in higher numbers during the drought, or the drought predisposed to Sinkobo? So I fail to sort of dismiss those figures based on overinflation only, because nowadays the traditional way of looking for a pathogen leading to a disease alone is no more. Now things are working, they gang up, such that you can actually be killed by a commensal, something you have lived with for a long time, simply because the parameters around it have changed. So overall, the statistics we have calculated, we have added to date, that is from 2015, now with the extension of the disease into Shorobe and into the Panhandle, those are the numbers farmers will tell you. So you can do the maths. That 18,000 multiplied by the average price of an animal in Maum, you are literally talking millions, which has gone away from the farmers. The numbers of farmers infected, it doesn't only add to 1 to 421. That's the whole economy of Northwest. You know, farmers don't bank this money. They spend it, they send kids to school. So the impact goes really to the individual farmers infected. But also, these are the numbers of animals which have been dipped and treated. You should know that dipping is actually a whole head approach. You don't dip those which are infected, but you treat those which are infected. So out of the numbers we have shown, almost 200 and something so far, these are the numbers of animals only which we've been able to dip during the campaign. So you can see the compliance here is less than 0.0 something percent by the farmers. You know, mortalities, as you see now, they've gone very high. Almost 17,000 cattle which have died. Goats, you're talking almost 18,000. Sheep, horses, donkeys. So these are huge numbers, really huge numbers. What are the control challenges we have picked up? That's a classic case of a chronic dermatophillosis cattle you see in Ngamiland. The thing about the causative agents being Dermatophilus congolensis, it goes under this dormant stage. And that's a survival stage for dermatophillosis. If you don't really deal with that dormant stage, it will always be there. The animals can go fat, you can always sell, but it's there, just waiting for the conducive environment to spring up and it will hit you. So that dormant stage can last months and even years. So we're actually breeding animals with a dormant infection of dermatophillosis. So it only becomes active again when the conditions of warmth and moisture prevail, and it starts to migrate through the skin and get transmitted to other animals. So that vicious cycle is what you see on most of the animals in Ngamiland like that. Okay. Now, obviously now it's exacerbated by skin trauma, and that's where the ticks comes from. And this misnomer is not a tick-borne disease, it's tick-associated. Yeah? So the ticks play that trauma effect. So farmers see ticks, they see dermatophillosis in Ngamiland, but it's not necessarily. Of course, we've isolated dermatophillosis on ticks, but those were fed ticks, probably just from the blood they fed from the animals which are infected. Okay, so that's the point where ticks comes in. You have to control that trauma things. Prolonged wet conditions, and that's where the floods comes in. So you've got a situation where during the driest of the season, these ticks, because they are passively transmitted, they come to the floodplains in high numbers, they concentrate there. You also have all these animals now coming to the floodplains because that's where the green shoots are. So you have really a meeting point of high tick concentration and all the animals in Ngamiland. Okay? And it's all a mishmash there. Now, it's very interesting to us, what we've also observed in the field is there is this carcass carrion avoidance. You know, carrions are just scavengers. We know dogs don't eat dogs, isn't it? So the carnivore carrion avoidance is a well-known that they don't eat it for eco-evolutionary reasons. But it has been interesting to us that these carcasses of dermatophilosis, scavengers avoid them. Even vultures, dogs, hyenas, they don't go next to them. It has fascinated us. Yeah, so they are all there lying. You come to Ngamiland, you find them in the middle of town during the heavy infestation. So this is something we have observed. Why, we really don't know. They are not scavenged on these carcasses. They'll be lying there until they rot. The second point we have realized, obviously, is there has been management practice challenges in Ngamiland in general. Like I've said, this is a common extensive grazing setup. The animals swim from one river bank to the other one. They get wet, and that creates a conducive environment for the re-emergence of the dormant dermatophilosis. So you could see, and you can see these animals, they enjoy, in Ngamiland, this grass, they call it mugu. So these animals, they are spending the whole day up to their neck, just grazing these green shoots for the good part of the year until the rains come, because the floods come in April. These animals have to cross from one bank to another one, go in. It's all dry in Ngamiland except along the river and the riverbank. So they are ever swimming. And immediately the water goes down, the rains come. So you can see the amount of time, almost more than 60% of the time, a typical wetland living cow in Ngamiland has to have a wet skin. And that's the thing about so you also get illegal movement of livestock, like the drought season animals. People this year, the past year, they were moving animals as far as carrying into the delta for the good grazing. Now, when the rains come, they take them back. Some of those now have sinkobo. So that's a bit where you get the spread. And we've also observed poor compliance. You have seen the number of animals which have been dipped, almost 8,000. This is a free dip by government. Say, come and dip your animals. And they can only do 8,000 out of the 100 and something thousand. So compliance, there is an issue. That has been all the issue in Ngamiland. And this is a situation where now you get likelihood of us now propagating antimicrobial resistance, be it the acaricide version or the drugs we're using to treat the cases. And also now there's also an issue of grazing away from the floodplains. We have tried that with FMD back in the days. I think Bonzinge will share those stories where we had boreholes up in the panhandle away from the river. Is it a way of keeping animals dry? We know the hard-veiled animals are not being infected, but those in the wetlands. Should we avoid the wetlands as far as grazing is concerned? That's up for that. Limited funds by farmers to procure dips and drugs. I mean, I'll just give you an example there of a typically used drug, which is tetracycline, costs you about $350 and can only do 4 adult animals at 400 kg in 3 injections. So you can see if you're going through a herd of so many animals, it's actually not usable, just as well as the dip. The pour-ons are preferred because if you are using water-based dips, you are also acting like the floods, isn't it? you are wetting that skin, and the dip only work on ticks. It doesn't work on the antibiotic, on the bacteria. So the bacteria, we just take it as a good bath, and it just re-emerges. So you want to stick to the pour-on drugs. What has happened?
I think there's a problem with the network, so it's
okay.
Yeah.
So I can
Dismiss.
Yeah. Then
Oh.
we do.
There you go.
Yeah. Okay. So the other action, the other component we have, and now I'm hitting on you, PS and the minister, is actually extension service shortfall to backstop farmers. I mean, you know, we need to be there to backstop farmers, encourage them to comply to the prescribed protocols or intervention measures. So if you are away because of the short numbers, that encouragement also falls wayside. So transport limitation to actually conduct this surveillance and attend to cases for proper diagnostic records. I put in a case of best noitis here to a farmer that's sinkobo, you know. So misdiagnosis also count in terms of the figures. But if you are really we need to nip it and get the correct diagnosis. So also, some things we can't avoid. As we go about our business, vaccinating for FMD, which is very critical, we are moving Kgofa from one animal to another with our needles. It could be minimal, but it plays a point, something to consider. So the biosafety measures we have in place can help that. So use of water-based dips, they, of course, like you said, they encourage that regrowth of the dormant bacteria, but they are the cheaper version. So the consideration there, which we have not actually incorporated in these dips, is to consider adding in copper sulfate, which has got that drying agent, drying element on the skin, and actually bactericidal. So it will keep the dip free from the bacteria, particularly if you are letting the animals go through a water bath. So it's always good to add copper sulfate because it's going to keep the dermatophilus away from the dip for continued dipping. But these are the things we are trying to put on the table for consideration in developing a protocol. Now, the last bit on extension shortfalls is the over-reliance on tetracycline. We know traditionally it's kimakonatsote, but we do feel there's over-reliance on it. And we better look at tetracycline in terms of Sinkobo. It's cheaper version, farmers can buy over the counter. But, we have to know how it works. It's a protein binding drugs. It doesn't only bind to the proteins of the antigen you are trying to kill. It also binds to the proteins of the host. So all in all, if you are using it over time, it's catabolic. It actually breaks down the protein. So it's actually making the animal scrawny. Okay? And it's now also, so if you are using it on an animal like that, which is down, you're actually killing that animal. And farmers in Ngamiland, no matter how good you are in extension saves, you will never make them give 2 doses to an animal. They will tell you, go away with your extension saves. Because of that, they've realized you give it once, at least you are stuck it in a balance between the animals. Because, this is a bacteriostatic. It just stops the bacteria growing and using the animal immune system now to clear it. So if you give it, and it kills those very fight back of the animals. So the animals will never clear it. It will just go into this chronic stage and end up like that. So this is the point about using tetracycline. So at certain point, it should be a clinical judgment. These are very weak animals. I need to go straight on a bactericide. I need to kill it because the animal can't help itself. The animal is too weak. I don't want to put it under a catabolic process by the drug. The animal is too weak. It can't mount a clearing immune response to this, even if when I arrested the bacteria. And that is not available to the farmers. And to me, I think that's the reason why animals are dying despite our efforts. So for the way forward, we though through our studies we have just looked at the intensity of infection, we have not gone in details now to identify these ticks. So that's why we came up with this Kgofa project. So we are going to identify ticks all of Botswana, everywhere, including national parks, because to be honest, the ticks we know about are those which are brought for diagnostics from livestock rearing areas. We don't know anything about our parks because no one has ever gone there. And this is the first project which led us into the parks because we randomized almost 100 sites, and my colleagues will present on that. What ticks have we found by species, where, and we are going further to look at what pathogens they harbor, and that's really where we should be. Standard ticks and tick-borne disease management protocol, I think that's something we have to devise, led by the competent authority, so that right now everybody is doing whatever they want, and we really cannot go ahead with that kind of approach in this era of antimicrobial resistance, and so we need to come up with that. So we'll have clause sharing what they are doing. It could be a template going forward, because it has to have all the management practice to it and also the chemotherapy approach to it. So we have brought them on board. They'll share their story. How are they trying to help the farmers? Obviously, DVS is the critical stakeholder, the lead agent in all those, because it needs to be approved, it needs to be shared. And the farmers, of course, they have also a play, be it from their belief sides of things or from their knowledge part of things, both the classroom and organic. So to that, I just want to thank you all and acknowledge this Dr. Mutsu's cow, which gave him 3 cows, I think, many years ago. And that's what we want towards the 5 million heads. Thanks very much.
Thank you, Dr. Babayani, for that beautiful presentation. I can assure you these treatment protocols